The purpose of this video is to analyze a photo of San Jacinto Peak, taken by the YouTube channel Jtolan Media. It has been alleged that more than 7,000 feet of the mountain is hidden by the geographical curve of the Earth. I will demonstrate that this assertion is untrue and the various analyses of this image are fundamentally flawed. I will start with some basic image facts. First, an excerpt from a course on photogrammetry, which is the art of measuring from photographs.
Cameras actually measure directions. So, if this is a real 3D world, this should be the projection center of my camera. It actually generates an image which is upside down. And what the camera basically does, every of these pixels here in this image corresponds to a ray that goes through the 3D world. So every point which lies on that green ray will actually be mapped to this pixel. So if there's an object here and here, let's say a bird flying through the scene, it will map the bird, simply the closest one. And I have no idea if this is the bird here, an object over here, or the top of the mountain. So cameras are just devices which measure directions. Nothing else.
As was explained, cameras measure direction. Cameras have an optical axis which generally corresponds with the center of a photo. Tilt affects how an image is projected onto the film or camera sensor. Tilt should be considered when making measurements. You can determine the tilt of a camera by finding the image center. You can find the center of a photo by marking 2 lines across each diagonal. The camera was tilted from horizontal when the image was captured. The intersection of the X is nearly as high as the peak of San Jacinto. What also need to be taken into account is occlusion. Occlusion is nothing more than obstruction of a background object by an object in the foreground. In order to know what the lowest possible features in the line of sight are, we need to consider occlusion. Now, each landmark will be listed in order of closest to observer location to furthest from observer location. I will accompany each landmark with information on the line of sight, elevation, distance, third-party image of the landmark and the location of landmark in Jtolan's image. Also included will be an image of a representation of the landmark in an orthographic geometrical construction using both a 7/6 ball and a flat surface. Observer. Distance 0 miles. Elevation 150 feet equals 0.02 miles. Horizon. Distance 16.2 miles. Elevation 0 feet. Venice Fishing Pier. Distance 19 miles. Elevation 45 feet estimated. Marina del Rey. Distance 20 miles. Elevation mean sea level equals MSL. Westchester Medical Plaza. Distance 23.7 miles. Elevation above MSL 130, building height 159 feet, total 289 feet equals 0.05 miles. Morningside Park. Distance 27 miles. Elevation above MSL 210 feet equals 0.04 miles. San Juan Hill. Distance 61 miles. Elevation above MSL 1,782 feet equals 0.33 miles. Black Mountain. Distance 118 miles. Elevation above MSL 7,772 feet equals 1.47 miles. San Jacinto Peak. Distance 123 miles. Elevation above MSL 10,800 feet equals 2.04 miles. Turquoise Peak. Distance 123 miles. Elevation above MSL 8,846 feet equals 1.67 miles. Now we will take those data points and place them into a two-scale geometric construction. Lines will originate at the observer. They will be placed so they intersect the top of each landmark. As demonstrated by the previously shown image, any object at a further distance and below the respective line will have those features obstructed from any possible view. Using this method, we can determine what elevations should and should not be visible. I will now explain the numbers in the image. The vertical line is the line of sight to the peak of San Jacinto. The horizontal ticks align to the tops of each landmark used in the geometry construction. The numbers indicate the number of feet that would be obstructed at the elevation and distance of San Jacinto. For the horizon to Morningside Park obstructs 580.8 feet of San Jacinto. From the top of Morningside Park to the top of San Juan Hill obstructs 422.4 feet of San Jacinto. From the top of San Juan Hill to the top of Black Mountain obstructs 686.4 feet of San Jacinto. This leaves 2,323.2 feet of San Jacinto unobstructed and visible according to the globe. Something is missing though. Where is the eye level at San Jacinto? I will now measure that and add it to the image. The eye level is 1,953.6 feet visible above the horizon, and 316.8 feet visible above Black Mountain according to the globe. Obviously, there is a big problem with the globe geometry and the eye level. These buildings are University Hall and Hannon Library. These are on the Loyola Marymount campus. Hannon Library sits at a 150 feet elevation. This puts the real-world eye level at this red line. This fact alone is completely inconsistent with the globe prediction. The globe model does not conform to the image even using the standard refraction model. And that is not the only problem. The horizon also shows that the image is inconsistent with the globe model. The globe predicts the horizon is 16 miles away. For the image we can clearly see the Venice fishing pier 19 miles away. To the left you can see a break in the shoreline. This is a breakwater that is also 19 miles away. We can also observe the same at the inlet of Marina del Rey. Marina del Rey is 20 miles away from the observer. The water's surface is clearly visible at a further distance than left and right shorelines. If the globe model were correct, it would be impossible to see the water's surface beyond its predicted horizon. I will now explain the numbers in the flat Earth image. The vertical line is the line of sight to the peak of San Jacinto. The horizontal ticks align to the tops of each landmark used in the geometry construction. The numbers indicate the number of feet that would be obstructed at the elevation and distance of San Jacinto. For the horizon to Morningside Park obstructs 586.08 feet of San Jacinto. From the top of Morningside Park to the top of San Juan Hill obstructs 2,835 feet of San Jacinto. From the top of San Juan Hill to the top of Black Mountain obstructs 4,593.6 feet of San Jacinto. This leaves 2,787.84 feet of San Jacinto visible above Black Mountain. A simple analysis of this image indicates that the scales are distorted between the top and bottoms of the mountain. Either the elevations above Black Mountain are stretched, or the elevations below Black Mountain are compressed. This phenomena exists using the globe numbers as well, though there is a smaller distortion of scale. This is due to the globe's standard refraction model being included, whereas the flat Earth construction has no account for refraction. A plausible explanation is the fact refraction is unequal on an upward slope versus a downward slope. In this case, the upward slope to the tops of mountains is greater than the lower elevations. In consequence of this, the direction in which light reaches the camera sensor will come from a higher angle as a function of height relative to the camera. In surveying, this is observed and called unequal refraction error. You can read more about it in an empirical assessment of refraction error in leveling as a function of survey order and environment bulletin 2115 by the USGS. A full treatment of terrestrial refraction will be in a follow-up video. Thanks for watching.